Hello students, today we will discuss about zeros of a polynomial. So in the last class we have discussed about polynomial and now we will discuss the zeros. Now we consider a polynomial here, px equal to x square minus 5x plus 6. It's a polynomial because exponent or power of this variables are whole number. Now if we replace x, because x is a variable, so value of x may be any number. So suppose if we replace x equal to 1, so what happens when x becomes 1? That is, it becomes p1. That is, when we put x equal to 1 here, it becomes p1. So it becomes 1 square minus 5 into 1 plus 6. So is equal to 1 square means 1, 1 plus 6, 7, 7 minus 5. It is 2. That is, we get some values of this polynomial when we put x equal to 1. Now if we put suppose x equal to 2, what happen here? If we put x equal to p2, that is px, in place of x we write 2 here. So in place of x we have to write 2. It becomes 2 square minus 5 into 2 plus 6. So what happened? 2 square means 4. 4 plus 6. 4 plus 6 is 10. Minus 5 to the 10. So 10 minus 10, we get 0. Now if we put x equal to 0, then what happens? So p, that is 0. That is, in place of px we write p0. That is, in place of x we write 0. We get 0 square minus 5 into 0. 5x means 5 into x. So 5 into 0 plus 6 is equal to 0 square means 0. 5 into 0 means 0. So 0 minus 0 becomes 0. 0 plus 6, we get 6. Now if we put x equal to 3, so what happens? P3 is equal to 3 square minus 5 into 3 plus 6 is equal to 3 square means 9. 9 plus 6, 15. And minus 5 to the 15. So 15 minus 15. Again we get 0. Similarly, you can put any negative number also. Suppose x equal to, we put minus 1. That is p minus 1. If we put minus 1 here, we get minus 1 square minus 5 into x. That is 5 into minus 1 plus 6 is equal to, so minus 1 square is plus 1, minus plus 5 plus 6. That is 1 plus 5, that is 6, 6 plus 6, 12. That is, we get the values of px when we put x equal to 0, 1, 2, 3 or minus 1. Now for some value of x, the value of px becomes 0. Here, see. For some value of x, that is when x equal to 2 and x equal to 3, the value of px becomes 0. And this 2 and 3 is called the zeros of this polynomial px. That is, for what value the value of a polynomial become 0 is called the zero of the polynomial. Now we consider a linear polynomial px equal to x minus 1. The power of x is 1, highest power, that is degree is 1 here. So it's called linear polynomial. Now we have to find the zero of this polynomial. That is, for what value of x the value of px becomes 0. That is, px should be 0 for the value of x. So from here we write, so px equal to 0. So px means x minus 1, that is x minus 1 should be 0. So what is the value of x then? If we take this minus 1 to the right side, that is x equal to minus 1 becomes plus 1. That is x equal to 1. We get x equal to 1 is the 0 of the polynomial px. That is when we have to find the zeros of a polynomial, then we compare the px or the polynomial with 0. Then we get the values or zeros of this polynomial. Like this. Now we consider px equal to 2. So it's also a polynomial. It's called constant polynomial. So now we have to find the zeros of the constant polynomial. Is it possible that for some values of x, this px becomes 0? That is 2b px equal to 0. That means 2 must be also equal to 0. There is no x, that is we can write this 2 x to the power 0 equal to 0. Is there any value of x to the power 0 equal to 1? That is, if we put x equal to suppose 1 or 2 or 3 or 4, any number, this to the power 0 becomes 1, anything to the power 0 equal to 1, 2 into 1 becomes 2, not 0. That is, if it is a constant polynomial, then we can't find it, the 0. That is, there is no zeros of a constant polynomial. Remember it. For a constant polynomial, there is no zeros. Next, we take px equal to 0. That is a 0 polynomial. So, for what value of x, px becomes 0. So, already px is 0. That is, we get 0 can be written as 0 into 1, 0, that is x to the power 0, the variable. So, if we put x equal to 1, 1 to the power 0, 1 into 0, 0. If we put x equal to 2, 2 to the power 0 is 1 into 0, 0. If we put suppose x equal to 100 to the power 0, that is 1 into 0, 0. That is, if we put x equal to any real number, it may be positive, it may be negative, it may be root over, it may be finite decimal, it may be infinite decimal, it may be terminating decimal, it may be non-terminating decimal, that is any real number. If you put for x, then this to the power 0 is always 1, anything to the power 0 equal to 1, and into 0 is always 0. That is, every real number be the zeros of a 0 polynomial. Remember it. That is, for any real number, you can put any real number to get px equal to 0 here. So, this. Now, from the above discussion, we can conclude that the definition of 0, that is, a 0 of a polynomial px, that is px, if the polynomial is in terms of y, you can write py also. If the polynomial is in terms of t, then you can write pt, same. But generally, polynomials are written in x to the power something like this. So, we write px here. So, polynomial px is a number c. C may be any real number. That is, 0 of a polynomial be any real number c such that is for which tc equal to 0. That means, if we put c in place of x, then this polynomial becomes 0. This is the definition of 0 of this polynomial. Now see what we observed from these examples and definition. So, first we observed that a zero of a polynomial need not be a zero. So in the first example, for x equal to 2 and x equal to 3, the px becomes 0. That is, for that polynomial, 2 and 3 are the zeros. So zeros of a polynomial need not be 0. That is, there may be some other number. So next observation number 2 is, next, see, 0 may be a 0 of a polynomial. So for some polynomial, the 0 of this polynomial may be 0. Let us suppose if we take px equal to x square plus twice x. X square plus twice x is a polynomial. So if we put x equal to 0 here, 0 square plus 2 into 0, that is 0 plus 0 becomes 0. That is, for x equal to 0, the px becomes 0. That is, this type of polynomial, the 0 of the polynomial may be this 0. So next observation number 3, this. So this is number 3. Every linear polynomial has 1 and only one 0. That is, if suppose px equal to x minus 1. We have discussed already. So for what value of x, this becomes 0. Only 1. If you put x equal to 1, then 1 minus 1 becomes 0. That is, 0 of this polynomial is only x equal to 1. And no other value of x, this px becomes 0. If we write, suppose px equal to, suppose here px equal to x plus 2, then what happens? Or what value of x, this px becomes 0? X equal to minus 2. That is, minus 2 plus 2 becomes 0. That is, for x equal to minus 2 only, this polynomial become 0. That is, there is only one 0 of this polynomial, which is minus 2. Next, number 4. A polynomial can have more than one 0. For example, the first example, px was x square minus 5x plus 6. And for that polynomial we get that for x equal to 2 and x equal to 3, the polynomial becomes 0. That is, for a quadratic polynomial we get 2 zeros. And similarly, if the polynomial is cubic polynomial, that is, the degree of this polynomial is 3, then we have 3 zeros. If the degree of a polynomial is 4, that is, there is x to the power 4 in that polynomial, we get 4 zeros, like this. That is, a polynomial, according to their degrees, they have more than one zeros. Remember, for linear polynomial, there is 1 0. For quadratic polynomial, there are 2 zeros. For cubic polynomial, there are 3 zeros. If the degree is 4, that is, x to the power 4 or t to the power 4 or u to the power 4 are there, then that type of polynomial have 4 zeros.